Hello, my name is Sean Goodrich. Today I'm going to be going over repeated roots for linear differential equations of the second order. Um, just some quick housekeeping things that I'm going to go over in case you haven't been using this. Um, our variable is going to be m in this situation, so for the quadratic formula, which can come in handy, especially in some of these situations, it's m equals negative b plus or minus the square root of b squared minus 4ac all over 2 times a. The other thing you can do is factoring, which is finding the two numbers whose product is C and the sum is B. I just wanted to put that out there really quick, just as a general refresher for anybody who's only been using the quadratic formula or anybody who's only been using factoring to find the solutions to their problems. So the first problem we're going to go over is find the general solution for y double prime minus 6y prime plus 9y equals 0. And then it also has an initial condition of y0 equals 4 and y prime 0 equals 0. So we're going to be solving for those two things. Now, from the topic, you know it's going to be a repeated root. It's just we're going to go over what form it needs to go in and different ways to solve for the repeated root. So in this situation, we're going to be using factoring. So it's we're going to change this from y prime or y double prime to m squared minus 6m plus 9 equals 0. And remember the 9, because there's no prime, has no m. So now we're going to find the two numbers whose product is C and the sum is B, and we're not going to use the quadratic formula in this situation. So we know that negative 3 times negative 3 equals 9, and if you add the two, it equals negative 6. So m minus 3 times m minus 3 now equals 0. And now we know that m1 equals m2 equals 3. So in this situation, we have a repeated root. So now what we need to do is go over what the general equation should look like for a repeated root in this situation. So we know that it should be y of x equals c1e to the, we'll call it mx, plus c2e to the mx. And in this situation, we need to make sure that there's two independent variables. But if you look at it, just because there's a second constant doesn't mean there's technically a second variable or second independent variable. So what we're going to do is we're going to put an x out here to differentiate the two to make it a second independent variable. Um, what and this is a trend that you can follow out. So if we had a repeated root for y triple prime plus a number here, y double prime plus